Welcome! My name is Z, and I'm your host for the Framework Developer Bootcamp. This show is for people who want to become web or mobile developers. Really, anyone who wants to learn programming will learn about new technologies and coding techniques each show. My goal for this show is to give you a taste of the kind of work developers do, and the tools they use for every project. Today, I'll be giving an introduction to Python, a beloved programming language that is used in many fields. It's used in computer science courses at many colleges and universities in the United States. It's also the language of choice of many scientists and researchers due to the expansive and well-supported scientific packages available. Outside of academia, web application frameworks using Python such as Django and Flask are also popular as well. In this session, we'll go over some basic Python syntax, such as assignments, conditions, and loops. We'll conclude this session by creating a small program that will encrypt a string of words using Caesar cipher, as well as decrypt and encrypt the strings with the correct key. A quick note on Caesar cipher. It's one of the earliest known encryption techniques, named after Julius Caesar, who used it to encrypt military transmissions. To encrypt the message with Caesar cipher, you shift all of the letters of the messages by a specific value on the alphabet. For example, if the shift value is 3, the message A, B, C would become D, E, F. As the A shift the 3 letters down, the alphabet is D, B shift the 3 letters down, the alphabet is E, etc. To ensure compatibility, we'll be running all the examples on C9, a cloud-based web development platform. During each episode of Framework, I'll be inviting you to follow along with me. As you're watching, don't be afraid to pause the video or watch it more than once, so you can enter the code or type in the commands right along with me. Thanks for watching Framework. Let's get started. Once the workspace is created, this is the screen you should be seeing. The first thing we're going to do is to check the Python version. So in the terminal, we're going to type Python -- version. So here, notice that in C9, Python 2.7 is used. The newest version as of late 2017 is 3.6. Version 2.7 is used because some packages are still relying on it. We are going to use version 3 today because support for 2 is going to end soon, and version 3 is where Python is headed, therefore the most beneficial for you to be familiar with. To use Python 3 in C9, we have to use the command python 3. And we could check the version by typing in -- version. And here we're using Python 3.4, which is good enough. Before we start writing any programs in Python, we're going to play around with the Python language in the Python interactive shell. An interactive shell is basically a terminal program where you could type in code in a specific language, and that code is executed in real time. To start the shell, we type in Python 3 and hit enter. And here we are in the Python interactive shell. The first thing we're going to do here is to do some assignments. For example, I could say x is equal to 5. Now we've assigned the numeric 5 to x. So x becomes 5. Or rather, x has 5. We could also assign strings. For example, y is equal to hello. And now y has hello. We can assign many other things, such as objects, lists, but I'll leave it for you to try it out. The next thing we're going to do is arithmetic. We could do addition, 5 plus 5. We could do subtraction, 5 minus 2. We could do multiplication, 5 times 10. And division. Okay, so the next thing we're going to do are loops. There are 2 types of loops that we're going to cover today. There is a while loop and there's a for loop. So this is what a while loop looks like. So while true or false, and you could replace the true with a condition that evaluates to either true or false. So while true, rather, this is probably better. We'll have x is equal to 0.
So while x is less than 10, hit enter, and then put 2 spaces. This lets the compiler to know that we're within the while loop now by putting a space here. So right now we're typing within the while loop. So what we're going to do is we're going to print out x, and then hit enter again. And then we'll have to put 2 more spaces. And then we'll increment x by 1. Oh, excuse me. So this is a while loop. So what this is saying is, while x is equal to 0, we're going to print it out, and we're going to increment 1. And as long as x is less than 10, we're going to repeat this until this condition is no longer true. And then the program is just going to skip this block and keep going. Okay? So the next thing the next loop that we're going to cover is the for loop. So, for example, if we have a list such as z is equal to 1, 2, 3, 4, 5. Now we have a list. If we want to iterate through the list, we could use a while loop. For example, we could say while x is less than the length of z, we could, excuse me, we could print z at x and then we could increment next. Oh, we also have to reset x back to 0 because from a previous program, x is actually right now at 9. So it's already longer than the length of z when we're starting. So we're going to reset x to 0 and then try that again. And there we are. We just printed every element in z. Now this is nice, but there's a different way of doing it that's simpler. For example, I could say for element in z, we're going to print element. See, we're achieving the same thing, except this is much easier to read, right? So we have for element in z, so for each of the element, we print it. This is a different way of going about it depending on what you're trying to do. If you're working with a list, the for loop is a better way of going through the list. But if you're working with something else that's not a list, you may want to use a while loop. So the next thing we're going to cover are if statements. So this is what if statements look like. If x is equal to 0, print yes. And we can see what x is right now. So x is 5. 5 is not equal to 0, so nothing got printed. Let's say if x is 0 right now, and then we're going to run the same thing again. Now yes is printed. So if statements give you a way to control the flow of the program. So depending on what condition the program is in right now, we may want to selectively execute a set of code. So that's what if statements allow you to do. The next thing we're going to cover are functions. Functions help to organize the code so that it's not only easier to read and understand, but it also allows for reuse. So for example, if we want to check if a number is 0, we could type if, let's say, y is 0. And if it is 0, we could say print yes. We could also say else print no. So y currently is not 0. Let's take a look and see what y is. So y right now is hello. So hello is not 0. So we could type this entire thing out every time to check whether something's 0 or not. Or we could put it in the function, such as def is 0. So def here allows us to define a function. And we're going to define a function called is0. And then we're going to take in an input. Let's call it something else. Let's call it user input, because I think input is actually a reserved word here. So here's how we define the function that's called is0, and it takes a user input. And then here we're going to say if user input is 0, we're going to print yes, else no. Okay, so here's a small function that checks if something's 0. So we could call it by just typing is 0, and then you could give it an input. So let's just say 5 as the input. And this is no. If we put is 0, 10, no. So is 0, 0. Says yes. So 0 is 0. So you see that if we put this code in a function, we don't have to type it over and over, and we could just reuse it by simply calling the function. So now we have some tools under our belt. We're going to build a small app that can encrypt and decrypt messages using Caesar Cipher. We're going to exit out of the interactive shell and create a file to put our code. To exit the interactive shell, we could type in exit, and then followed by parentheses. So here I created a file called Caesar_cipher.py, and the pi is short for Python. You could either create a file by typing in touch Caesar_cipher.py, or you could right click on the left hand side and select new file. Okay, let's open up the file. So in this file, we're going to define 4 functions. We're going to define a function called encrypt, which takes in the message and the key. And we're going to put a placeholder here for now, pass. Otherwise, the program is going to complain that it is empty. We're also going to define a function called decrypt, which is going to decrypt our message, and it takes a ciphertext. A ciphertext is basically an encrypted text. And we're also going to take the key, which is what we're going to use to decrypt the ciphertext. And we're going to place a placeholder here. We're also going to define a function called shift_char, which is going to take a character and a distance, how much to shift it by. Put a placeholder here. And the last thing we're going to do is to define a function called limit shift, which is going to take a number that's a representation of the character in the start, the range, and end. We're going to pass. And before we keep going, I just want to explain a little bit how this shifting works. So all characters in Python are represented by numeric values because computers only understand numbers. For example, the lowercase letter a is represented by the number 97. and the lowercase letter z is represented by the number 122. And we can actually take a look at it in an interactive shell if we want. If we want to fire up Python interactive shell, Python 3. So for example, for the letter A, we could type in OR and then parentheses, and then we could give it single quote A and then end single quote and then close parentheses. And it will actually give us the number that represents A. And if we want to turn a number into a character, we could use the str command. Let's say 97. Oh, excuse me. It's CHR, not STR. 97. And that's going to give us the letter. So using that, we could shift the characters down the alphabet when given a number. So for example, to shift the lowercase letter a down 2 steps, we could first turn it into its respective number, and then add 2 to it, and then turn it back into a letter. And that's going to give us C. So something like this. So let's say A or X is equal to A, the character A. And then we could do OR on X, which is going to give us 97, and then we could add 2 to it. And then let's get rid of the space here. And then we could apply the char function, and then that's going to give us C. So that's basically an overview of how our algorithm works. So let's implement the functions. So here in the encrypt, we want to make sure that the user passes us a message that's actually a string, because it doesn't make sense to shift the number by, let's say, 5 spots, or even like an exclamation mark. So first thing we're going to do is assert that, and then we're going to use isInstance, and we're going to check that the message is a string. If it's not a string, we're going to give this message, and then we're also going to assert that the key is actually an integer, because it doesn't make sense to shift, let's say, a message by letter A. So here we're going to say the key must be an integer. And lastly, we're going to return the result of this for char and message. Okay, so we're actually use what's known as a list comprehension here. So what's going on here is that we're taking every character in the message, and then we're applying the shift char function here, which we haven't defined yet, but we'll get to in a bit. So this function is going to shift every character by the specific key. And then once it's shifted, we're building another list of new characters that are shifted. And then lastly, we're joining them to form a string here. So that's all we're going to do in the encrypt function. So the decrypt function is going to be very similar. First, we assert that ciphertext is indeed a string. Must be a string, similar to encrypt, and assert key is an integer. And lastly, we're going to do almost the same thing as encrypt. We're going to call shift char. But here, instead of using the key, we're going to use the negative of key. Because if you think about it, if you're encrypting the letter A with the key 2, you're going to get C. To decrypt C, we're really giving it a negative of the key. So -2, so it moves backwards by 2. So here we're going to put a negative or a minus key for chart and ciphertext. And just a quick note here, ciphertext just means a text that's encrypted. Okay, so simple. The next thing we're going to do is to implement the limit shift. So what this does is, for example, if we're on letter Z right now, which we could take a look in the command line, excuse me, that's 122. So what happens when we go to 123? So if we try to turn 123 into a character, it's a curly brace. That's not what we want. Let's say if we get a string that has the letter Z in there and want to shift it over by 1, we're going to get a curly brace. But instead we actually want it to go to A, which would make sense. So this is what this function does. This function takes in an input, which is the numeric, the number that represents the letter, and it also takes in the start and end of the range. And the start of the range in this instance would be the lowercase a, and the end of the range is going to be lowercase z. So when you actually give it a z and tell it to shift over by 1, it's actually going to give you an a instead of what's after a z, which is the curly brace in Python. So to do that, we're going to check if numeric is greater than end. So if it is, numeric is equal to numeric minus the end, which is going to give us the difference, and minus 1, which is going to take care of the offset, and then plus the start. So here, let's say if we get letter Z here, which is 122, lowercase letter z, 122. And the end here will also be 122 because z is the end. So that would be 122 minus 122, or rather, we're actually going to get 123 because we've shifted over by 1 already. So this would be 123 minus the end, which is z, 122, which is going to give us the difference of 1. We subtract it, which is going to give us 0, and then we add start. And the start here is a, so this whole thing, if we've shifted to the right by 1 from z, now we're going to get 8. So else, if it's going the other direction, or rather here we're going to use an else if statement. Numeric is less than start. So let's say if we're at A right now and we're actually decrypting it, we're going to the left, less than 97, we're also going to get a symbol. So we want to take care of that here. So numeric, and this is very similar to the above, numeric minus start plus 1 plus end. And you could plug in a number and test this out and see what you get, which is going to help you understand what's actually going on here. So if it's greater than the end, so if it's beyond the end or if it's before the start, we want to apply this to make sure that it's between the start and the end. So at the end here, we're going to say return numeric. That's what we're going to do. So this is going to make sure that the character that we pass in is between start and end, the start and end that we give. So last but not least, the shift chart function. I'm going to get rid of the placeholder. So this is the meat of our algorithm. This is where all the shifting happens. So to start, we're going to define the range for the lowercase and uppercase characters. Because like you see earlier, so for lowercase a, it's 97, but it's very different for uppercase a. So if we do ORD, uppercase a here, we get a different number. And then if we do z, it's not 122, like the lowercase z. Now it's 90. So we're actually going to record that range here. So lowercase, we could use the range function, and we're going to define it as 97 to 122, like we saw earlier. And the uppercase rather right here we have to say 123 because this number is exclusive in Python, meaning that this number is actually not a part of the range. So the number before it is a part of the range. So here, when I write 97 to 123, it's actually 97 to 122 here. So for uppercase, we're going to type in 65, 91. And this is the same thing. We really wanted the range to go up to 90. But since this is exclusive, and this is just a Python thing here, since this is exclusive, we have to put one more here. Okay? And then we're going to turn the char that we get here from the function into a number by using the OR function. So now, to the algorithm. So if the number that represents a character is in the lowercase, so meaning if the character is lowercase, we're going to shift it by the distance. So with this is actually the same as writing is equal to numeric plus distance. These two are the same thing. This is just like a shorter way of writing it. Okay, so distance, and we also want to take care of the fact that if someone passes a key that's greater than 26, we want to use the mod operation here. So if we get a 27, it's really a 1. So a mod operation is actually just the remainder operator, if you've not heard of it. So it gives you the remainder. So if you have 27 mod 26, you get 1 with a remainder of 1. So in this case, it will actually give you a 1. So we're going to do mod 26, but only if distance is greater or equal to 0, because we don't want negative distance here. Else, if it is a negative distance, we're going to turn to positive and mod it, and then turn it back to a negative. Because for negative 27, we really want to get negative 1 out of it. But negative 27 mod 26 is not negative 1. So we want to turn the distance, if it's negative, into a positive number, and then mod it, and then turn it back to a negative number. So this is what we're doing here. Distance, excuse me. And so negative distance. So this is if it's negative. So if it's positive, we could just do this. But if it's negative, we're going to turn this distance into positive. So negative of a negative is a positive. We're going to mod it by 26. And then we're going to take this whole thing and turn it back into negative. So once we shifted the letter, now we want to make sure it's within limit. So we apply, so for numeric, we apply the limit shift function, and then we put the numeric in there. And then for the start, we're going to turn the lowercase range into a list and use the first element of the list, which is going to be 97. And for the end here, remember, limit shift takes a numeric, a start, and an end. And for the end here, we could turn lowercase into a list, and then use the pop function, which is going to give us the last element in the list. And the last element here, remember 123 is actually exclusive, so we're not including 123. So the last element here would be 122. Okay, so that's for our lowercase. And then if it is lowercase, we could just return it here. We could turn it back into a character, and then end the function here. However, so this is for lowercase. So if it's uppercase, we do something very similar. We're going to use else if numeric in uppercase. Numeric is plus or equal to distance mod 26. If distance is greater than 0, very similar to what we have up there. Else negative distance mod 26. Okay, so here we're also going to limit the shift by taking a numeric and then specifying the start and end of the range, which we're going to list uppercase instead. We're going to use the first element, and we're going to use the last element. Oh, might have had a typo here. Oh, no, it's fine. Okay. So, and last but not least, we're going to turn this into a character. So now, if it's in lowercase, we're going to do our thing and then return it. Otherwise, if it's uppercase, we're going to do our own thing. What about if you have an exclamation mark or a period or a comma? For those, we just return them without doing anything. So once it goes through these two if statements and it still hasn't returned, the function still hasn't terminated with a value, we could say return chart, because we don't want to transform those things, those punctuations. So there it is, Caesar cipher. We could test it out in the terminal by using import Caesar cipher as CC. So for example, I could say cc.encrypt, and we give it a message, try ABC, and then we shift it by 2 over, we get CDE. And we can even decrypt this by calling cc decrypt. And since it moves everything to the left by 2, we get YZ8. So that seems to be working fine. And that's it. You just build your first Python program.
In this session, you learned some basics of Python, a popular programming language that's used in classrooms, web development, artificial intelligence, and more. You learned the basic syntax of the language, such as assignments, loops, conditions, and functions. And you build a pair of functions that can encrypt and decrypt a message using Caesar cipher. Congratulations! Now you have some basic knowledge of Python. If you enjoy this show, why not give the Framework Professional Developer Program a shot? We help you become a professional developer in as little as 20 weeks. Our program is online, but everyone in the program has their own instructor, so your questions are always answered. You can try the program for free. Just sign up at learntoprogram.tv/p/try-framework. See you next time.